invite our Professor Balint Nemeth from BME, Hungary, to give a short presentation on the excellent technology, how to do de-icing on the transmission line.
Thank you very much, Mr. Tong. I hope you can hear me and see my screen. Perfect. Thank you so much. So, good afternoon, ladies and gentlemen. My name is Balint Nemeth. I work in the Budapest Technical University. And on behalf of our work package, I would like to show you a short introduction about the dynamic line rating and for de-icing what we did during the FLEXITRANSTORE project. Thank you very much, Nikos, for the nice overview and introduction of the whole concept, and especially the dynamic line rating, what you already told and mentioned that what was the main aim and what was the main reason that we used the dynamic line rating in the FLEXITRANSTORE project. Just a couple of more information. What I would like to add is that if you see the real assets in our power system, including the substation and the overhead line as the two big categories, the bottleneck of this system, if we are checking the flexibility of the whole asset, is most of the time the overhead line. If you see the substation devices, the reserve, what they have, like a transformer or any other equipment in the substation, is much, much bigger, and the static rating is much above than what our overhead line normally or usually have. So that's the main aim, and that's the main issue or the main background why we are using the dynamic line rating, especially for the overhead line, because most of the time the reserve what we have on the whole overhead line is much smaller, and those are the criticalest area or the criticalest point of our system. Including this dynamic line rating, we built up a complete system, and we tested and made the demonstration in our FLEXITRANSTORE project. Let's go step by step. So what was our address problem is one side, as I mentioned, the dynamic line rating as to get more capability and more reserve from the line. The other is real cases, which was happening during the past, much before when we started our FLEXITRANSTORE project. So the power line security and the reliability mainly depends on the thermal behavior of the phase conductors and the effect of the extreme weather conditions, such as the power line icing. We were mainly concentrating of the different kind of extreme weather condition, mainly the icing and the icing events which can be detected and also which can be predicted based on the dynamic line system. If you see these photos that you can see on the down part of my presentation, this was real cases. Unfortunately, in 2014 in Slovenia, there were two parallel lines which was destroyed because of very high and very extreme icing events. Unfortunately, at that time, this power line didn't contain the different sensoring and the different DLR technology, which could prevent this bad case. The other, if I'm following the power line security and also the reliability, is the real cases, what we did during the demonstration and using the very special technology. The sensors that we installed, some of the sensors that we installed was capable to take photos, to give and detect the real icing, and also the algorithm that we developed during the FLEXITRANSTORE project and also made the demonstration of it was capable to predict the different type of icing, as I will show you later on in the following slides. But these photos are real photos from the line from Slovenia, especially those line which was earlier in 2014, unfortunately destroyed by ice, and then after they rebuilt, then actually rebuilt it, and then after we used the sensoring technology in that particular line. So what is the objects and the scope of the project itself? DLR, as shortly we call it, so the dynamic line rating allows a higher utilization of the existing power lines. as I mentioned in the beginning, which provides, based on the international research and publications, and what we also found in our demonstration, so it provides around 20 to 30% additional transfer capacity in average of 95% of the time frame. In case of the extreme weather conditions, serious failures can be prevented, and it can be used by the different sensoring technology. And also there is we call it anti-icing, prevention, which means that using the Joule heating of the conductor itself, so giving a higher power of the conductor, we can preheat, we can heat up the conductor itself using also the same sensoring technology. And thanks to these preheat, we can prevent the icing on the conductor, and then there could not happen any failing events. The DRR-based ice prediction system is able to determine the possibility of the ice accreditation of the power line by using the same weather forecast as we are using for the DRR system. In this project, we developed a very nice modeling system, and this method was first in the world which could make differences and predict the 3 different types of icing events, which is the wet snow, the glaze, and the hard rime. And not only just preventing, but also it can says concrete information about the radius and the mass of the icing, depending on the weather forecast data what we got from the National Weather Services. Based on this information, we could calculate the thickness of the ice, and if we could calculate it, we could also say that what is the load that we need to implement to that particular overhead line. And last but not least, the actual thermal and physical state of the conductor are also gathered for the better utilization of the existing system by the system operators. How the system was built up, what we used in the FLEXITRANSTORE project. As it was also mentioned by Nikos, we had 2 demo areas. One was in Slovenia and the other one was in Bulgaria, as I will show you later on in more details. Exactly the same or the similar system was developed in both cases. So in the left-hand side, you can see that on the conductor, we have the sensors that we are installed, and also we had the local measurement, the local weather stations. These information, what we collected from the sensors, like the conductor temperature or the sag measurement or the icing detection, and also from the local weather service, local weather stations, we were collecting the different weather data like wind direction, wind speed, temperature, humidity, and so on and so on. All this information, including the weather forecast, which was coming from the National Weather Services, both from Slovenia and also from Bulgaria. So this information went into a server after the calculation model, which model was calculating one side the de-icing algorithm and calculating the actual icing event and also the prevention to the next 20 minutes, 1 hour, 4 hours, depending on what kind of prediction data we got. The outcome was of the expert system is the evaluation and also the increasing of the load, our anti-icing, and also the galloping if we need to do it. And also in the right side, you can see some of the photos of the GUI that we used in our modeling. So as I mentioned, we had 2 areas and 2 countries. One was in Bulgaria, supported by the University of Bulgaria and also the TSO of Bulgaria. One line was monitored during one line monitoring was implemented, which was already installed. And during the project, we also implemented 3 other different kind of monitoring sensors. So altogether 4 different sensors. One of the idea was that in the 2 different countries, we would like to do and use the DLR for testing the sensors itself from different point of view. In Bulgaria, we use 4 different sensors to see and compare the different sensor reliability and also usability of the sensors itself. We implemented these 4 different sensors to the same line, exactly not too far from each other, as you can see also in the right side photo. We also implemented 4 weather stations from different manufacturers as well, based on the same or similar idea, as I mentioned, to compare the results what they was measuring. Sorry, in Slovenia, We also implemented 4 sensors plus 2 weather stations. But here the background idea was a little bit different, that because the 3 line monitor sensors and also the 2 weather stations was coming from the same manufacturer, the reason was to figure out and try to build up a model based on the critical sag analyzation, that what is the maximum or what is the minimum number of dynamic line rating sensors that we need to implement into an overhead line if we would like to cover the whole line area. So here we had 4 same sensor or 4 similar manufacturer sensor, and also the 2 weather station that we used based on the same IT map as I introduced you in the previous slide. Based on the data from the 13 field equipment, 8 line monitoring sensors and 5 weather station, the DLR-based line monitoring expert system was implemented at both demonstration. And also the expert system was operated for more than 2 years independently from the 2 countries, on which the base data analysis was carried out to evaluate the system results. You can see a couple of photos again from the different systems. The left upside, you could see also that including to the model, we implemented the complete 2-dimensional drawing of the whole lines. We made different sections, and sag by sag, we made the analysis. In the right side, you can see up also a photo about the icing system, which shows green light if there was no icing, or red light if there could be any icing, and so on and so on. Based upon the key achievement and results, we not only just installed the existing available sensors from the market, but also, as Nikos was mentioning, the FLEXITRANSTORE project had a big R&D part as well, mainly concentrating to the first part of our project. And then after, during the 2-year time, we were making the demonstration. What kind of development and research what we did? We developed and built up models. One model was, we call it white box model, that you can see the right down part. This model was containing and built off the available international rules and models, like the IEEE model and the CGRE model, and the different environment and also conductor parameter was used as the input parameter. But you can see in the down part area, we also added different features like the outer strand diameter, or also the inclination, which was missing in both from the models. Also, we made an extended physical model, which means that we added the precipitation and the humidity as a new factor, as a new cooling factor of the overhead line as well. Also, we build up a black box model. Black box model, we call that we are using an AI system, exactly neural network system. And during the first part of the demonstration, it was the teaching algorithm. So 1 year of teaching. And then after the 2nd year, the black box model was as a standalone model, and then working and using the similar input parameters, but without any physical background, just the 3rd year of learning time. Then we were comparing the output of this model, as I will show you later, the exact results. Also, BME implemented the icing prediction model based on also different international models, but we were the first in the world who implemented into one system the different kind of icing models. And also we try to build up first, not only just saying that there will be any kind of icing event, but also trying to say the thicknesses of the ice itself. OTLM and BME ice detection model, which not only just giving a prediction, but based on inclination of the sensor, what could measure, and also based on the photos that you could see, and I will show you later on, we could also exactly see if there was any kind of icing, and based on the camera, which was included into the OTLM sensor itself, you could see the real icing, what is going on. And the BME sag model, which was also finally included into the model itself. So all these was developed during the FLEXITRANSTORE first part of it, and then after we did the demonstration as well. So what are the lessons learned? Just very quickly, the black box model was able to determine the conductor temperature with the same accuracy as the line monitoring sensor measurement uncertainty, which is around ±2 Celsius. In the left-hand side, you can see the white box model. In the right-hand side, you can see the black box model, and you can see the temperature difference is pretty close or pretty much the same. If we say about a half or maximum 1 Celsius difference, or even the 2, as I wrote above, which is the uncertainty of the measurement of the sensor. So that's why we are saying that the black box model is the same, working as the same accuracy as the normal sensoring one. Based on the thermal modeling of the phase conductor, the average surplus transmission capacity gained by the BME extended white box model, gathering the static line rating, was in the range of 25–30% in the project. So it was also pretty similar than the other available international publications and results. And also the achieved sag modeling accuracy with the BME model was in the range of the 25–35 centimeter. You can see the different calculated ampacity based on the different stations, and also with the red line, you can see the static one in horizontal. And about the icing event and the icing prediction model, ice prediction model is able to distinguish several ice types, as I mentioned, the wet snow, the graze, and the hard rime, and also the mass of the ice leaves and its radius also determined. Unfortunately, we didn't have so many different cases, or fortunately, depends on who you are asking. But during the demonstration period, only minor icing events had been occurred, but we had, which was successfully predicted with the icing prediction model, and the icing detection system based on the online monitoring sensor was also, captured by the photo, as you can see in the right downside, that there was some icing, minor icing during the project itself. Based on the ice detection and the prediction system, the risk of the icing events can be significantly decreased, which is a key benefit of the implemented expert system. In the left down graph, you can see with red color the expected ice thickness in millimeters, and in blue one, the ambient temperature, how it is going down during the time period. So finally, just a short conclusion. What is the recommendation based on our work package inside of the FLEXITRANSTORE project? From the technology point of view, the utilization of the DLR system with the introduced extended functions like the sag modeling, conductor temperature tracking, ice detection, and prediction is recommended to increase the operational safety for both the TSO and the DSO level. The policy, the DLR-based expert system have to be adjusted to the requirements of the given TSO and DSO, meaning that IT security policy, time frame of the data gathering, calculation and visualization, and so on, in order to reach the system that can be used effectively in the practice. And related to the regulation, the introduced system is able to meet the clearance regulations due to the developed SAG model. Finally, I would like to thank you the whole consortium during the fantastic time that we could have together, and also a lot of lessons learned. Especially, I would like to say thank you for those partners who were involved from the research area, Bulgaria, and also the TSO, and also from Slovenia, Electro Ljubljana, who supported a lot us, and also the technology providers, especially OTLM, who was very helpful and cooperative during the whole project side. Thank you very much, ladies and gentlemen. If you have any question, just feel free to ask me now or later on.
Thank you very much, Balint, Professor Balint. It was very interesting or very inspiring to hear that you were the first one in the world to integrate many operation model of this SAC model, and also de-icing DSR into a single platform so that we can support this thing. Is there any burning question? If not, so thank again, Professor Balint, and I would like to, I would like to invite Mark Norton from SmartRide to share a very innovative technology.
Actually, Hong, sorry to interrupt. I see that there is a question in the chat.
What action are taken if icing is predicted? Okay, so Balint, can you answer quickly?
Of course, just a minute. I'm trying to see the question.
What action are taken if icing is predicted?
Okay. So the action. So the action, if we are predicting any kind of icing event, what we could do is to give an information of the TSO or the DSO dispatcher center, and then based on their strategy, they can make some reallocation or redispatching, depends on the system of the overhead lines, which means that a higher load can be transferred to that particular overhead line. And if we can predict the icing event, it means that we can heat up in advance the conductor for above the 0 temperature or above the 1.5, 1.2 temperature Celsius. And then the icing event cannot happen on that particular line.
So thank you very much, Balint, due to the timing. So I could like to suggest if you can maybe reserve if you have other question. So you can reserve until the final session so that we can even return back to the topic. So